Welcome back, everyone. We're diving deep into the world of code switching in speech recognition today. You've been looking into how these systems can understand conversations that switch between different languages, right?
Fascinating stuff, really.
For sure. It's like teaching a computer to understand a secret code that keeps changing. So how do they actually do it? What are the typical methods they're using?
Well, one common approach is they try to figure out which language is being used at any given moment.
Wow, so like a linguistic detective.
Exactly. They call this language model determination. And then there's word mapping, where they basically translate words between languages in real time.
Like a built-in dictionary that the system can use on the fly. But that sounds super complicated, especially with all the little differences between languages. Are there more advanced techniques?
Oh, absolutely. They're using things like contextualized CTC, which is like giving the system a short-term memory to help it predict the next word, even if it's in a different language.
Contextualized CTC. That's a mouthful. Could you break that down a little more?
Sure. Imagine someone's talking and they switch from English to, say, Mandarin. Contextualized CTC helps the system remember the English words it just heard and use that context to predict the next Mandarin word.
Ah, I see. So it's all about giving the system as much context as possible to help it navigate those language shifts.
Precisely.
And you mentioned word mapping earlier. Can you give us a real-world example of how that works?
Sure. Imagine someone switching between English and Mandarin in the middle of a sentence. Word mapping would help the system find the equivalent Mandarin phrase for the English words, so it can understand the whole sentence.
So the system is kind of like a multilingual interpreter, bridging the
Oh,
gaps between different languages.
that's a good way to put it.
But what about things like pre-trained models and transfer learning? Are those being used in code switching research too?
Oh, definitely. They're using pre-trained models, which are already trained on huge amounts of data, to speed up the learning process for code switching.
So it's like giving the system a head start, right?
Exactly. They take a model that already understands language structure and fine-tune it on code switch data.
That's really cool. It sounds like researchers are always finding ways to make these systems more efficient. But speaking of efficiency, how large are these code switching systems? Are we talking room-sized computers?
Well, they are complex, but not quite room size. We're talking about large, deep learning models like RNNT and transformers.
RNNT transformers. Those sound pretty intimidating.
Basically, they're vast networks of interconnected nodes, like a super complex neural network. They process tons of data to learn patterns and make predictions.
So it's not just about algorithms, it's also about having the power to process all that data.
That's right.
Now, let's talk about languages. Which ones are researchers usually focusing on for code switching?
You often see them focusing on languages where there's a lot of available data, like Mandarin English or Hindi English.
So they need lots of data to train these systems. But what about other language combinations? Have there been any efforts on Southeast Asian languages?
Yes, actually. There's a fascinating study using a corpus called SEAM, which looks specifically at Mandarin English code switching in Southeast Asia.
Seeing. That sounds interesting. Why is this corpus so important?
Well, because it shows us how people in Southeast Asia actually code switch between Mandarin and English. It gives us a real-world view of how languages mix in that region.
That's really cool. Sounds like a goldmine of information.
Absolutely. Having real-world examples is crucial for training systems that can understand the nuances of how people really speak.
Definitely. So we've talked about the methods, the importance of data, and even some language combinations. But what about the data itself? What kinds of data do they use to train these systems?
They usually use a mix of monolingual data, which is in just one language, and code switch data. The challenge is finding enough high-quality code switched data.
I can imagine that finding real-world examples of code switching could be tricky. What are they doing about that?
Well, this is where things get really interesting. They're actually creating synthetic code-switched data. It's almost like building a linguistic Frankenstein.
Synthetic data, like artificial code switching. How does that even work?
One technique called speech collage takes bits of audio from monolingual corpora and stitches them together to make synthetic code-switched sentences.
Wow. So it's like a language mashup.
Exactly. It's a clever way to work around the data scarcity problem.
But is all this synthetic data made by hand?
Luckily, no. They're also using techniques inspired by machine translation to automatically generate code-switched text.
So they're teaching computers to create code-switched sentences on their own.
In a way, yes.
That's amazing. We've talked about large, deep learning models, but Just how big are these systems in reality?
We're talking about models with millions, sometimes billions of parameters. They need a
Wow.
lot of processing power to run.
Wow, that's impressive. It sounds like training these systems is a massive undertaking, but is it always about making them bigger and bigger?
That's where configurable multilingual models come in. These are adaptable systems that can be adjusted to recognize different language combinations.
Ah, so instead of building a separate model for every language combination, you have one flexible system.
Exactly.
That's really clever. But shifting gears a bit, I'm fascinated by what makes code-switched speech so challenging for these systems. It's not just about the words themselves, right?
You're right. One of the biggest challenges is figuring out where one language ends and another begins. It's called language boundary detection.
I can see how that would be tricky,
Yeah.
especially with how smoothly people switch between languages.
Yeah.
How are they tackling that?
One way is using language identification. The system tries to figure out what language is being spoken at any moment.
Like a built-in language decoder.
Exactly. Another technique is boundary-aware prediction, where the system is specifically trained to pay attention to the points where language switching happens.
So it's like this system is learning to anticipate those moments of code switching.
Pres-
But how do they know if these systems are getting better? Are there special metrics they use to evaluate code switching in text and speech?
There are. For example, the M metric measures how accurately the system identifies those language switch points.
Makes sense. But what about the overall smoothness and naturalness of the recognized speech? Are there metrics for that too?
Yes, there are. Metrics like the I metric look at how smoothly the system handles those transitions between languages to make sure the recognized speech sounds natural.
It's not just about recognizing the words, but also capturing the flow of natural code-switched speech. That's fascinating. It really highlights the complexity of this field.
It certainly does. Code switching ASR is about more than just words. It's about understanding the nuances, the rhythm, the blending of languages that makes human communication so unique.
That's a great way to put it.
We've only just scratched the surface.
Well, I'm definitely ready to dig deeper into this world of code switching. We've covered a lot of ground, from the basics to the challenges of data collection to how they evaluate these systems. This has been super informative.
I agree. It's always exciting to explore the cutting edge of language technology, especially something as dynamic as code switching.
Before we wrap up this part, I'm curious about the scale of these systems. You mentioned they can have millions, even billions of parameters. Can you tell us more about that? Just how massive are these systems?
We're talking about models that need massive amounts of processing power. Imagine huge networks processing information at incredible speeds, constantly learning and adapting.
Wow, that's a powerful image. It sounds like training these systems is a real feat.
It certainly is. As we continue this deep dive, we'll uncover even more about the challenges and successes of building these complex systems.
I can't wait. It sounds like there's a lot more to explore.
It really is amazing how these systems are pushing the boundaries in language technology. And as we create these more sophisticated models, we're actually learning more about how complex human language is, too.
That's a really good point. This research isn't just improving speech recognition, it's helping us understand how we use language to communicate and express ourselves.
Absolutely. And code switching is a perfect example of that complexity. It's not just about switching between languages, it's about mixing them in a way that's fluid and expressive, often very personal.
It's like a dance with language, weaving different languages together to create meaning and identity.
Exactly. And the deeper we go into code switching ASR, the more we appreciate the richness of those linguistic tapestries.
That's a beautiful way to put it.
Yeah.
It also makes me think about the cultural side of this research. Code switching is often connected to specific communities and cultures.
That's a really important point. We have to be sensitive to cultural differences when we develop these systems. We don't want them to perpetuate any biases or stereotypes.
It's a good reminder that technology should be used to bring people together, not create divisions.
Absolutely. And that's why it's so important to include diverse voices when we develop and use these technologies. We need to make sure they benefit everyone.
It's about creating technology that's inclusive and reflects how diverse human language and culture really are. But let's shift gears a little and talk about the practical challenges in code switching ASR. We talked about data, but what other hurdles are researchers facing?
Well, one big challenge is making these systems robust. A lot of code switching ASR systems work well in controlled environments, but struggle in real-world situations. With background noise, different accents, unpredictable speech patterns.
And that makes sense. It's like the difference between giving a presentation and having a conversation in a noisy restaurant. The real world throws a lot of curveballs.
Exactly. So future research needs to focus on systems that can handle these real-world challenges, like maybe exploring new noise reduction techniques or developing models that aren't so sensitive to different accents.
Making these systems more adaptable and reliable so they can handle the chaos of real-world conversations.
Right. Another challenge is scalability. Right now, training and using these complex models can be expensive. They need powerful hardware and lots of resources.
So it's not just about the algorithms, it's also about having the right infrastructure.
Exactly. As we move towards more complex models that need even more data, we have to find ways to make them more efficient and scalable, maybe by exploring new hardware or developing better training algorithms.
It's about making this technology more practical for everyday use. Speaking of which, I'm curious about the impact of code switching ASR on different industries. Are there certain sectors that would benefit most from these advancements?
One that comes to mind right away is healthcare. Imagine doctors and patients communicating easily no matter what language they speak.
That would be incredible, especially in places where patients might not speak the main language.
Absolutely. Code switching ASR could be used to create real-time translation systems for medical appointments, so doctors and patients understand each other clearly. It could also help transcribe and analyze medical records, making it easier to share information across language barriers.
So it's about making sure everyone has access to quality healthcare regardless of their language.
Exactly. Another area with huge potential is education. Think about classrooms where students can learn and interact in their native languages, even if it's different from the teacher's language.
That would be amazing. A much more inclusive and engaging environment, especially for students from different linguistic backgrounds.
Exactly. Code switching ASR could be used to develop personalized language learning tools that adapt to each student. It could also create interactive learning environments where students can practice their language skills naturally without worrying about making mistakes.
Empowering students to learn in their own linguistic space, while still being part of a larger, more diverse classroom.
Exactly. And as we think about these applications in healthcare, education, and other areas, it's important to remember that technology is just a tool. We have to use it responsibly and ethically.
That's a great point. We need to be aware of potential biases in these systems. The last thing we want is technology that excludes certain groups of people.
I couldn't agree more. We have to address issues of fairness and inclusion right from the start. That means making sure these systems are trained on diverse data that represents all the different languages and accents in the real world.
So we're building systems that are accurate and fair, which means being careful about potential bias in the data and the algorithms.
Exactly. And it also means working with diverse communities, listening to their concerns, and making sure these technologies benefit everyone.
It's about collaboration, transparency, and understanding the social and cultural context where these technologies will be used.
Absolutely. As we keep exploring code switching ASR, it's crucial to keep these ethical considerations in mind. We need to make sure these powerful technologies are used to create a more inclusive world for all.
That's a great point to end on. It reminds us that technology isn't just about progress, it's about responsibility and impact.
Definitely. As we wrap up this part of our deep dive, it's worth taking a moment to appreciate the incredible progress in code switching ASR. We've come a long way in a short time.
It really is remarkable. And looking ahead, I'm excited to see what new breakthroughs and applications emerge in this field.
Me too. The future of code switching ASR is bright, with so many possibilities for bridging language divides and creating understanding across cultures.
But before we get too far ahead, let's go back to the technical side for a bit. We talked about the challenges of robustness and scalability. What are researchers doing to overcome those hurdles?
One promising area is developing more sophisticated noise reduction techniques. Imagine algorithms that can filter out background noise and focus on the speaker's voice, even in noisy environments.
That would be incredible, especially for real-world situations where noise is almost always present.
You're right. Researchers are also looking for ways to make these systems less sensitive to different accents. Imagine models that can understand different accents and dialects.
That's fascinating. That would make these systems much more adaptable and reliable.
It would. And then there's scalability. Researchers are exploring new hardware and more efficient training algorithms to make these systems more manageable and less expensive.
So making this technology more accessible for everyone.
Exactly. Another focus is on incorporating context to improve accuracy. Think about systems that consider the whole conversation, the speaker's background, and other factors to understand the meaning better.
That's a really interesting idea. giving these systems a deeper understanding of the world so they can interpret speech in context.
Precisely. As we keep pushing the boundaries of code switching ASR, we'll see even more innovative solutions to these challenges and unlock the full potential of this amazing technology.
It really feels like we're on the edge of some big changes in code switching ASR. But with all this talk about the technology, it's easy to forget about the people. How is this actually being used to help people in their lives?
That's such an important question. This research isn't just theoretical, it's about creating technology that actually makes a difference.
So where are we seeing the biggest impact right now? What are some real-world examples?
One area where we're seeing a lot of progress is with voice assistants and smart home devices. Imagine being able to talk to these devices naturally, using your own code-switched speech.
That would be so convenient. No more having to change how you speak for the technology to understand.
Exactly. And even more than convenience, it could make these devices more inclusive and accessible for people who code switch all the time.
It's about removing those language barriers and letting people communicate authentically.
Precisely. And another really exciting area is education. Think about language learning apps that could actually understand and respond to code-switched speech, giving personalized feedback.
That would be amazing for language learners. It would be like having a conversation, not just a lesson.
Right. And it's not just about learning new languages. Code-switching ASR could also be used to make classrooms more inclusive for students who code-switch naturally. Imagine a system that could transcribe and translate lectures in real time so every student can follow along, regardless of their language background.
That would be incredible. It would really help create equal opportunities for all students.
Absolutely. And we could even see this technology being used in healthcare, customer service, entertainment. Imagine doctors and patients understanding each other perfectly, no matter what languages they speak. Or customer service that adapts to the customer's language. Or subtitles and dubbing that actually capture the nuances of code-switched dialogue.
Wow, the possibilities are huge. It sounds like code switching ASR could completely change how we communicate. But as with any powerful technology, there are some ethical things we need to consider.
That's very true. As these code-switching systems become more advanced, it's crucial that we use them responsibly and ethically. We have to be very careful about bias, discrimination, and misuse.
We want this technology to empower people, not to harm or exclude them.
Exactly. We need to design and use these systems in a way that respects diversity, promotes inclusivity, and benefits everyone.
It's a reminder that technology is a tool, and we have to use it wisely and ethically.
Absolutely. So as we wrap up this deep dive into the world of code-switching speech recognition, it's been quite a journey. We've explored the technical details, the exciting possibilities, and the ethical questions.
It really has been fascinating. We've learned about the amazing methods researchers are using, the challenges they face, and the potential this technology has to change so many parts of our lives.
And above all, we've seen that technology, when used for good, can be a powerful force for positive change. It can help us break down barriers, connect with each other, and create a more inclusive and understanding world.
That's a great takeaway. It's been a real pleasure learning about this with you and understanding just how complex and powerful code-switching ASR can be.
The feeling is mutual. And to everyone listening, thank you for joining us on this exploration. I hope it inspires you to keep learning about language technology and its impact on our world.
Until next time, keep those conversations going. May your words build bridges and create connections.